Very happy new year to everyone. Today we are doing some problems starting with the number of 1 bits. Starting the year. It's already 2nd January. Okay, starting the year with easy problem. Number of 1 bits. Given a positive integer and write a function that returns the number of set bits in its binary representation, also known as Hamming weight. So okay, we are given a number and we have to return how many bits are set in its binary representation, basically how many ones there are in in its binary form. So 11, which is 1011 in binary, has 3 ones. 128 has only one 1. This big number has a lot of ones, 30 ones. So yeah, if this function is called many times, how would you optimize it? Well, we can either use the recursion or I think bitwise operations. I always find them hard to remember. I always forget them. So maybe I'll start with the recursion solution, even though I know using those bitwise operations would be much easier. For example, we can easily spot a pattern in binary numbers. So it starts with 0, 1 and 1 0, 1 1 and 1 0 0, 1 0 1, I believe, for 5, 1 2, no, hang on, 0, this is 4, yeah, 1 0 1 and 1 1 0, 1 2 4 5, yeah, 4 5 6, 8, 1 0 0 1, and so on. 0 0 0 0 0 0 0 0 0 0 0 0 0 0 okay, 0. I don't like doing this, turning off the mic. There's noise. Well, we know we can use these two numbers as our piece conditions. Okay, if n is smaller than 2, just return the n. If n is 0, then it has 0 1. If n is 1, then it has only 1, and based on that we can check If it's a odd number, 4, 6, 7, 9, 8, 9. Well, 3 has 2 ones and it's an odd number. 5 has 2 ones, it's an odd number. 7 has 3 ones, it's an odd number. Two's half is 1 and 2 has same number of zeros as 1. 4's half is 2 and 4 has same number of ones as 2. 6 half is 3 and so 6 should have same number of zeros as its half. 2 1. Oh my god, I keep same. Okay, 6 half is 3, so 6 should have same number of ones as its as 3. 2 to 8 is even, have the same number of ones as 4, and this is true for all even even numbers. Yeah. For odd numbers, if it's 3, then I think we can half it. Okay, so I'm gonna say if n is smaller than 2, return n, and if n is an even number, then return so we need to keep a variable. Else if, well, that's just else case, return 5 minus 1 4. 4's half is 2, so 2 has 1, and we can add one extra element, add extra 1. For example, 9 has 2 set bits, so it should be equal to 1 plus result 1 plus 9's half. 9 minus 1 divide by 2. 9 minus 1 divided by 2. Okay, let's see. 1 and 9 minus 1 8. it divides by 2, so 1, and 1 will get 4 will get us 1, and with this extra 1 result becomes 2. Okay, so we can just say Okay, we don't need to subtract with 1. Sorry, we don't need to. We just, yeah, you can just subtract with 1. Let's see. Okay. Okay, it works. Not the best solution. Uh, is it linear, the complexity? Log n. And I think with bitwise operations, with the, oh god. Okay. Mm, well, let's try bitwise solution. I think I'm gonna make use of uh, right shift or left shift. So the idea is that I want to get the last bit, and I can check if it's a 1 or 0. If it's 1, I will increase my counter, and I will just keep going like this until the number becomes 0. So for example, this number, uh, is it right shift? Right shift. Yeah, we are shifting. Well, if I right shift this number with 1, we are shifting it to the left. These numbers to the left and to the right. So in next iteration, uh, in next iteration, uh, we'll have 0 0 0 0. In next iteration, we'll have one extra 0 at the front, and this one will shift one place, and just like this, we will have our 1. We will have this one at the right side, and we can increment our counter. How can we do that? How can we check if 1 is at the end, like if this current bit is 1? uh, can I make use of AND? This was the number, and if I AND this with 1, if it's a 1, uh, this was 9. After shifting right shifting by 1 with 1, it became 4, and then 4 became 2, and then 1. Interesting. I know all this. It is I forget it. Uh, yeah, we can just add this thing with 1. Or with the n minus 1. So let's try. So as long as n is greater than 0, I want to say let's keep a sum variable. Let's count set to 0 and return this count at the end. And right shift by 1, and is equal to n is equal to n. Well, if I do this, I will get a, if I and y1 0 0 0 1, and this is what I want. I want to say that n and 1, if if it gives me a 1, then increase my counter and right shift my n. What? Bad operand type for. What does that mean? Int and a boolean. Okay. Well, yes. So, like what? It will return a int then. So I can directly check. Plus. Okay. The solution was accepted. Last solution was accepted on 27 October. Okay, last time I did n minus 1. It's good to know, like it's like I've completely forgot. Hang on. I completely forgot about this solution, and like even though I had ideas, like I knew that okay, you have to like shift. By the way, see, I did not shift it to the right. Okay. It's always like interesting to see there are multiple ways to get the same solution, same answer, and yeah. Okay, let's move on to the next problem. Okay, closest. Given an array of points where point I have my mic's on. Given an array of points where point I is this pair x1 y1 represents a point on xy plane and an integer k. Return the k closest points to the origin. 0 0. You may return the answer in any order. The answer is guaranteed to be unique. Heap. Well, I need to use a priority queue in this one. So we are given a points on x y plane pairs, and we have to return k closest to the origin. K closest points from 0 and 0 using a distance formula. Math, divide, conquer. Geometry, sorting, heap, quicksil. Divide and conquer. The distance between this and this, square root of 10. So we don't actually need to calculate the square root. We just know just by looking that 8 is smaller than 10, so its square root would be smaller than 10. And square root. We only want the closest k points from the origin. So the answer is just okay. Priority queue. And priority queue will Q new and I need to specify some sort of constructor. Comparator, comparison. Well, we know the kind of output. Okay. What is the distance formula? Well, if 1 and 3 are my points on the plane, and if I want to calculate the distance between them, I will check. A minus B whole square is equal to A minus B A minus B A square. So that is A square minus A B minus BA what is 0 minus A1 multiply A1, same thing as the statement on the 15th line, is equal to A minus B. Only here I distributed this power. Okay, and we can do the same thing with the B. So I can say that A B 0 plus minus 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 is 1 plus b's 0 multiply b's 1 minus this whole formula should give us an integer, and based on the integer we can prioritize that point. So for example, these 2 points, we will get their distance as an integer. For example, 10. No. We'll, uh, mm, is this correct? Yes. Okay, let's try. For points, for point and points, just add everything to my queue. Point and for I is 0, as long as I is smaller than k, because we only need k elements, we need result is equal to integer and k. Result dot I is equal to q dot poll, and return the result. Illegal state of expression. It's like there has to be a syntax error in this. Points. Oh, wrong type. It's an array type. 1D array type. Expected 3 by 3. What does the formula say? What does the formula say? That you oh oh god, x minus x2. uh y1 b0 a1 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 b1 minus b1. Okay. Okay, I want to extract this into its own variable. I wonder how I would do this. What type is it? Is it int? I don't know. Constructor. It's a lambda expression. So I better put let's ask lead. How should I turn this lambda into a variable? Comparator, okay. Okay, got it. Thank you. Okay, this is a interface, comparator interface. Okay. Constructor. Let's pass it here. Let's see. Okay, works. Amazing, fine, good. Expected. Last solution was submitted on 1st November. Yep, I did same thing. Well, I initially got confused with these XY planes. I sort of assumed that this 1 and 3 are both, this one is x1 and this 3 is x2, but actually this is x1. No, I thought this is, I assumed this was x1 and this was y1. Yeah. Okay. Just want to see the solution with the divide and conquer. Oh, yeah, we gotta create pairs. Long compare. The next problem, basic calculator. I attempted this problem, and okay, let me show you my last submission. This is the code, and for some reason I am using two stacks, one for operands and one for operators, and like while writing this, somewhere here I realized, oh, I don't even need two stacks. So this is like so messy. I don't even know what's this. Yeah, and for handling parentheses, I created this very integer open parenthesis offset, and for some reason I'm checking the size of numbers, the stack that holds my numbers, and I'm checking its size, and if I'm checking if my stack which holds my other stack which holds my operators, if, yeah, by the way, it didn't even work. I don't know. Let's start from beginning. I know that only when one stack is needed, integer stack new stack, okay, only one stack is needed, and so need a sign to check if the number is negative or positive. Okay, let's go through the statement. Given a string as representing a valid expression, implement a basic calculator to evaluate it and return the result of the evaluation. You're not allowed to use any built-in functions which value. Okay, so they have given us basic examples, and our calculator should only support addition and subtraction, not multiplication and division. And really the tricky part is well, handling these parentheses, also handling negative numbers. So this -1, like because we are given a string as an input. So we can we might think, oh, it's like we can check character at each index, and if it's a minus, we might think, okay, uh, it's a minus, let's add it to, that means it's a minus number. Okay, one more thing, yeah, I just remember. There can be numbers greater than 9. So for example, given this input, this 4 can be 41, and since it's a string, we come across 4, we think, okay, 4 is 4, we add it to a stack, and then there is 1 after that. So we might get lost somewhere there. So we need to take care of these 2-3 things. The rest is easy. Think. Okay, how will I do it? Imagine this is my stack. I come across 1, I find 1, I add 1 to my stack. And then there is a plus. If let's define a current is equal to s dot char at some index, and if current is equal to plus or minus, let's do this, else if current is equal to minus, if at that time the size of stack is -1 sign, when it's negative sign, the next number is a negative number. If it's a positive number, we can just do this. While index is smaller than s length. Okay. let's handle let's handle adding numbers to the stack first. Well, if my current is I don't know, smaller than is smaller than or equal to 0 or greater than no, is greater than or is smaller than or equal to 9, then I know it's a number and it has to go into the stack. So I'm just gonna keep a number here like this, and well, if current is 1, we can just say okay, plus 1 should give us 1. Now the next number, and we add this one onto the stack. Now if this was 11, so that means the next number will also be 11, will also be 1, so we get one more 1, and now we okay, I can make this all else if cases, else if current is equal to open parenthesis, else if current is equal to close parenthesis, and index plus plus. Okay, and I defined a num variable in here, so I can say num, well, num multiply 10 plus do this first, num my plus current minus to get the integer. Okay, do I need to explicitly cast it into integer? We'll see, and I can add this put this onto my stack, push this onto my stack. Okay, and if it's a number, it will enter this if, and after doing things here, we are incrementing the pointer, we are coming back here. If the next number is also a number, not an operator, then we don't need to worry, because our num stores the value of the previous number, and we can easily make it a double digit number. But if the next thing is not a number, for example it's a plus sign, then we can make our num 0 again in every case. Okay. So far good. Now let's handle the plus case. So we got 1 onto my stack, Now if the sign is plus, but I can't quite perform this operation because I don't have enough numbers in my stack. I only have one number. So I also need to sign. Okay. I need to multiply this with a sign. Current num. Okay. Now when I come across a minus sign, I sort of know that the next there is going to be a number after this, and it's a negative number. So I update my sign, I get out of here, plus come back here, and the next number will have minus, it will be a negative number in my stack. In this case, -1. Now how do I handle plus and minus? Can I get some hints? Hmm. Can I check the size of my stack? If it's if it's equal to 2, if it's greater than 1, then I can do it. Hmm. 1 minus 1 plus 1 plus 1. If my stack size is greater than 1, do this. Then is equal stack pop base stack pop stack dot push a plus b. I'll do the same thing here. Oh, hang on. Do I really need to perform these evaluations as soon as I find a sign? I don't know. We'll see. Let's just see. Index is not defined. Okay, no problem. It's 0. Yeah. At the end, well, our stack should have one element. Oh, what is this? Actually, these need to be char. Why? Let's print my stack. Hoping I'm not. I'm not adding any white space to my plus 1. Okay, 1. Why minus 6? White space? Oh. One. There's a white space, and there is an add, and one more white space. 1, 2, 3, 4. You get one more. I don't think software. Can I do the evaluation here? Yeah, let's try. Even that passes, it will not work for complex cases. Because I haven't implemented any logic for the parentheses. But hey, what if it works? Yeah. Wait, why is it not working for this number? Because my logic is not right. Well, there is no sign in this number. This is just a number. What? That's why I can't just rely on the size of the stack to check, okay, if it's time to do evaluation. There has to be a sign, there has to be an operand too. That's interesting. Can I also add my operand to my stack? For example, this is my stack. We'll have 1 and then we get out plus. I add plus to my stack. And then we check, okay, what is the last item in the stack? If it's a number, then okay, add this, do this logic. Well, if it's not a number, if it's some kind of sign, stack. Now first of all, I will check. I can keep something like this, should eval, and if should eval is turned on, and if should eval is turned on, then I want to say, well, perform evaluation. And once you have done that, turn it back off. False. So let's move this. And once we should eval is true, for plus and minuses, should eval is true. Let's see. Okay. Yes, this is what I was looking for, a complex case, an edge case. Let's see what our program is doing with this input. Okay. This is not a valid. I read something somewhere. Is not used as unitary. Could be used as unitary operation. Okay. So minus could be used as a unitary. Minus is used as a unitary operation here. Huh. Interesting. Sad. Well, at this point, we set our sign to -1, and when we get here, sign is still -1. Minus minus should cancel, should give us 1. One plus 2, 3. So that means the sign should turn to -1. Doesn't look like I'm anywhere close to actual solution. Every number and running calculation will fit in 32-bit integer. I wonder when we come here, we set should eval to true, and then we come here again, and now should eval is true. So it tries to pop last 2 items from the stack, but there is only one number in the stack at this point. Oh, why aren't we getting any errors? Okay, let's just check some hints. Simple iterations to identify character one by one. One important thing is that the input, which means number is over. We can add previous number and start a new number. Push the previous result and sign into this See, sign into the stack. Set the result to 0. Just calculate the new result within the parentheses. Pop out the if it's a digit, then number. Okay, yeah. Result plus equal to the sign and number. Makes sense, makes sense, makes sense. Why haven't I thought of that? I mean, from 0 anyway. We push the, for open parentheses, we push the result first and then sign. Sign, reset the sign and result. Result plus okay. Wow, this solution is only making use of stack for open and closed parentheses. We don't even need stack for simple addition and subtraction. Of course, we don't even need a stack for simple addition and subtraction. It's no-brainer. Once we find okay, for example, this input. So sum so far is 1, and then we have our open parentheses. Then we put the sign, put the result and sign onto the stack. Result and sign. Sign is 1 because it's okay. All right, that's how we are handling the unitary minus. That's so smart. Okay, and then we reset both of these values. This is our stack. Then we get a 4. Because we reset the result last time, we get a 4, then we get a 5, then we get 2. So all this adds up to 11, and then we get closing parenthesis. So what we do is sign, yep, result plus is equal to number is 0, so we still have 4. Number is not 0. Yeah, but this all results in 0. Result is 11, so we have 11, then we reset number to 0, and then okay, then we pop the sign from stack, okay, 11, and then we pop the result we got before opening parenthesis started. That is 1. That's so intelligent, so easy. Okay, 12. Okay. While number is not 0, okay, well, learned a lot from the solution. This is actually a good solution. How can I upvote? It already has a lot of votes, so it's fine. So yeah, I think that was the video. I was able to do 2 questions, got stuck on this one, but still learned a lot, and that's why I'm doing this. And yeah, this is truly bad solution. Let's just submit it just to keep the track. Okay, thank you so much for watching. I'll see myself and everyone tomorrow.